Our research group is attempting to create a way to take high-quality images of the moon for less than $30. This means that every part of the picture-taking process must add up to less than $30, including all raw materials and the cost of developing the images. By high quality, we mean that the image has a lot of details, is not blurry, and can be printed in a 4x6 picture. We also require that the entire apparatus is easy enough to at least be used by high school students.
Before explaining our approach to this project, let's first go over a few basics of light properties and how they relate to our lenses. When light travels from one medium to another, the speed of light changes as it passes through, resulting in a bend in the light, or refraction. The focal length of either lens is the amount of space between the lens and the focal point. The focal point is where the light is brightest, since all of the light collected converges on this point. The focal point will vary inversely to the degree of curvature. The picture one gets through a refractor telescope will generally be upside down because, in essence, the image is reflected through the focal point.
We decided that there are two different approaches to take a picture of the moon. The first method is to create a refracting telescope. A refracting telescope has two lenses, the objective lens and the eyepiece lens. The objective lens allows light to enter the telescope, refracting the image in such a way that it becomes inverted. The eyepiece lens then refracts the image again, but with a shorter focal length than the objective lens. This interaction results in magnification of the original image. Once the telescope magnifies the image, a camera can then look through the eyepiece to capture the picture. The other approach is based on the concept of camera obscura. Camera obscura traditionally uses one lens, but in our design we want to use a second lens in order to create a magnification. After the light goes through the second lens, there is a mirror at a diagonal to flip the image right side up. The image is projected onto a screen, and then the digital camera can take a picture of that image.
There are several real-life applications that can result from being able to take digital images of the moon for less than $30. High school students will be able to study the moon more cost-efficiently. By creating a way to produce high-quality images of the moon for less than $30, schools will be able to provide close-up, hands-on interaction with the moon in an affordable way. Though a stretch, it is also possible that in creating a low-cost way to take pictures of the moon, this technique can be mass-produced, giving people everywhere access to the moon. Stay tuned to see what happens next.
Change keeps us together. Love pushes you away from me. We're down and out, I'm so weary. Keep on moving on, tight spirit. Find your rights another way. We'll find your heart.